So they've given me that negative 3 and 5 are zeros, or intercepts of my parabola, and that the maximum is 3. So for a parabola, I know that the maximum must happen at the vertex, and because my parabola is nice and symmetric, the vertex must be smack in the middle of those two intercepts. So smack in the middle of 3 and 5 is 1, right? Because it's 1, 2, 3 away, or 1, 2, 3, 4 away from there, and 1, 2, 3, 4 away from the 5. Yes. So my vertex is going to be at the point 1, 3. That's the maximum value of that parabola. That's as high as it goes. And there he is. So now, to find the equation, I want to start by using the fact if negative 3 and 5 are zeros, then x plus 3 and x minus 5 should be factors of my parabola, because negative 3 would make this 0, and 5 would make that 0, and that would be good. But I also know that if I multiply this by any constant a, the negative 3 would still make that 0, and 5 would still make that 0. So that a means that there's bunches of parabolas with intercepts at negative 3 and 5. Some just go higher, some are upside down, some are just super stretched out. So that a controls kind of the wideness of it, and to pick which particular parabola we want, we have to use the fact that it goes through that particular point to lock it down. So to figure out what that a is going to be in our case, we know that when x is 1, y should be 3. So 3 should equal a times 1 plus 3 times 1 minus 5. So 3 should equal a times 4 times a negative 4. So 3 should equal negative 16a. So negative 3 over 16 should equal a. And so when I write the equation for my parabola, I'm just going to replace that a with the negative 3 over 16. And that is the equation of the parabola we want. If you wanted to, this is an intercept form right now, you could multiply it out, FOIL it all out, and get to a standard form if you like. But that is a valid equation, and we'll leave it there.